Hey guys, welcome back. Today we're going to look at chapter 2, which is an introduction to motion. So without further ado, why don't we just go ahead and get going, shall we? All right. So section 1 is describing motion. So motion, if you look at it in the simplest way, is essentially movement in one direction. So the train can move forward along the track, or it can move backward along the track. So we're going to just start off with very, very basic motion, such as one direction. So going nyet, or nyet, or net, or nyet. Now we do have to talk about things called distance and displacement. So displacement is the change in the position of an object. So it's found by subtracting the final position by the initial. Now, distance is the actual full path you take. So if we look at this picture, you start here, this is your xi, your initial position, and you end here, xf, your final position. So what happens is you walk, do, swerve, up and over, down you go, do. So all of that is your distance. The distance is the whole path that you took. So every step would be counted. The displacement, though, is the straight line difference between where you started and where you end. So this green line here represents your displacement. It's you started here, you ended up here, that straight line distance or that straight line measurement, that would be your displacement. So where did you end up relative to where you began? It does not always equal the distance you traveled. As we saw with the previous picture, you went in that whole big weird swervy path, which was your distance, but the displacement was much smaller. So here's another example. A lizard begins at the 20 centimeter mark on a ruler. He runs to the 80 centimeter mark, and then he moves to the 50 centimeter mark. What's the displacement? Well, first, before we do that, let's talk about his distance. How much did he actually move? So he went from the 20 centimeter mark to the 80 centimeter mark. That's 60 centimeters in between there. And then he went from the 80 centimeter mark to the 50 centimeter mark. So that's 30 centimeters. So 60 plus 30, he moved a total of 90 centimeters. But his displacement is the difference between where he started and where he ended up. Where did he start? His initial, so delta x. The delta is a Greek letter, it means change in. So delta x, the change in position, equals xf, final position, minus xi, initial. So where did he start? He started at the 20 centimeter mark. Where did he end up? He ended up at the 50 centimeter mark. So what was his displacement? He started at 20, he ended at 50, 50 minus 20, was final minus initial, and you get 30 centimeters. Now, direction is very important. And sometimes we're going to use a positive or a negative sign to tell the direction. Now, here's the thing. In math class, I know that a negative number means less than 0. But in physics class, that's not what it means. It means opposite. So if we talk about something moving in a positive direction and then in the negative direction, we just mean it's going in the opposite direction. We know that positive and negatives are opposite each other, like how the two sides of a magnet are opposite each other, and how positive charges will attract negative charges because opposites attract. And that's very similar to here, what we're talking about when we assign a negative sign to a value. We're not saying that it's less of a value. We're saying that that value is experiencing something in the opposite direction, whether it's motion in the opposite direction or acceleration in the opposite direction. It's all about direction. Now, a lot of times, especially if we don't, talk about north, south, east, west, how we would define these as up is positive Well, what's opposite of up? Down. So down would be negative. So positive and negative, we see the opposites there. Right is positive. What's opposite right? Left. So left is negative. So up and right are the two positive value directions, and down and left are the two negative value directions. All right, let's move on to section 2. Speed and velocity. A lot of times people use these two terms in almost interchangeably, but they are a little bit different. So speed is how fast something moves. We know that. Velocity is speed in a given direction. So the difference between the two is we need to incorporate a direction with velocity. And we can talk about the average velocity, how it's the total displacement by the time interval that the displacement occurs. So remember, we said delta x equals xf minus xi. So that's change in position equals the final position minus the initial. We also have delta t. That's the change in time. So the final time minus the initial time. So if we take the change in the position divided by the change in time, we get our average velocity. So average velocity equals change in position over change in time. Position, you can also think about that as distance. Distance over time. See? Speed. But we just also talk about direction. Hi, Ricky. All right. So let's assume that the boy started and stopped in the same spot. So if we want to talk about that, we have to think about, all right, he wants to know what his average velocity is. Well, that change in position, that's actually a change in displacement, or that's displacement. Remember, we said displacement was your change in position. Where did you end up relative to where you started? Well, if you start and stop in the same place, that means you have no displacement because there's no change in position. If there's no change in position, that means you have zero average velocity. Now, it doesn't mean that you weren't moving and you didn't have speed. You did have speed while you were moving, but you did not have an average velocity because you did not have a change in position. And that's why we say direction is very important, because you went maybe 10 meters per second to the right, and then on the way back, 10 meters per second to the left, ended up at the same place, cancels out. Instantaneous velocity is not the same as the average velocity. Even when you're in a car driving, your speed is not exactly the same at every single moment in your travels. And that's what instantaneous velocity would be looking at. It's the objects, no speaking good today. It's the object's velocity at any given point in time. So a lot of times velocity time graphs would help to figure that out. And looking at slope, I'm not gonna ask you, at least right now, I'm not gonna ask you a whole lot about instantaneous velocity. A lot of times when I have you calculate it, you're gonna be looking for the average velocity. But it is good to know about instantaneous velocity. Our section 3 is on position time graphs. So position time graph, it helps to visualize the motion. Now the reason why it's called position time, we have the position on the y-axis and time across the x-axis. Now, the nice thing about it is that it shows motion and how it changes over time. So in 1 second, you moved 10 meters. Got it. In 2 seconds, you moved 20 meters, 3:30. So you're measuring how far you moved at each point in time, and then you graph it. Now, because of this, it allows for more accurate estimates of future motion. So we only kind of measured 5 seconds. But from this, could I make a prediction about how far someone would get in 10 seconds. Well, yeah, if I just keep following this lineup, I can figure it out. And then it would give me a very accurate estimate. Now, if you remember in math class, when you find the slope, it's rise over run. So y position over the x position. And that means that the vertical, the y position, is divided by the horizontal, or the x position. Vertical is position divided by the horizontal, which is time, position over time. Oh my goodness, delta x divided by delta t. So in other words, the slope tells you the velocity. It tells you the velocity. So a straight line for a slope means the object has a constant velocity. So when you see a nice straight line, it doesn't like bend or change or anything like that, it's going nice and smooth, it means that they have a constant velocity, meaning that they're going at the same speed in the same direction at each point that time is measured at. If you start seeing it kind of, bending and, maybe here, it doesn't keep going straight, it goes upward. That means you would have a sharp increase in your velocity. If it's more like that, then it would be a decrease in velocity. So let's take a look at some of these ideas and what they mean. Now we have some examples down here, and we're going to talk about the slopes and how it relates to the velocity. So if you look at here, we have on the bottom in the middle, x and t, and we have this constant straight line upwards. Now it's a straight line, so that means that it is constant velocity, and the fact that it's increasing like that means it has a positive slope. When it has a positive slope, it means that there's positive velocity. And all this means is that someone is moving forward. And that makes sense because as time goes by, their displacement increases, which means they're getting further away from their starting point. However, if you have a negative velocity, like this, or negative slope, it means negative velocity. Essentially means you're going backwards towards the starting position. Which makes sense because as time goes by, notice the displacement is getting smaller and smaller. So that means that you are getting closer to the original starting position. If it's just a straight horizontal line, that means that there is a zero slope, which means there's no velocity. And that's because if we look at it, that means that our change in position, there is no change in position. So if there's no change in position, that means you're either not moving from that spot or you are moving but coming right back to that spot somehow in a second. And that just can't really happen, especially since each time point you're still at that same spot. So you're not changing position, it must be zero velocity. And this is just kind of showing you different examples. So here we have slowing down. Here we have fast, steady speed. Here we have getting getting faster. And here we have steady, constant velocity for time. Then they're stationary, and then they're returning back to their previous location. All right. Section 4, we're just going to kind of mention the equation of motion. So if the initial position and constant velocity are known, so if we know xi and we know velocity, this equation can give us the position of x, so the final position of an object at any given time. And how we do is final position equals initial position plus velocity times the time that the change in time. xf equals xi plus v over t, or sorry, v times t. Now in a video, I will show you how we get that equation, how we derive it from the delta V equals delta X over delta T. But I will show you that in one of the other videos in the additional resources. So if you're like, where did that come from? Don't stress, don't stress. So the additional resources, we have a few science in pajamas. Once again, these are the ones I do. We have one on distance versus displacement. And we have one on speed versus velocity. We'll also derive the final position equation of motion, the one that we just talked about. That will be derived, and you'll see how to get that in that video. Then we have position time graphs for velocity. In terms of other video resources, we have a lot of them. We have Khan Academy Distance and Displacement Introduction. We have Khan Academy Distance and Displacement in 1 dimension. Don't memorize distance and displacement. Don't memorize what is velocity. Khan Academy Calculating Average Velocity or Speed. Khan Academy Instantaneous Speed and Velocity. And Khan Academy Position versus Time Graphs. All right. So I definitely recommend you guys checking some of these out. They will help you to kind of understand overall the things we've discussed. But if you have questions, hit me up in our Google Classroom, through email, in our actual classroom. Please don't be afraid to ask for clarification. That's what I'm here for. I will post this Prezi link into the video description so you have access to those additional resources. And in the meantime, you guys, just stay awesome, stay curious, stay safe and healthy. All right, guys, until next time, bye-bye.